chapter 4.7. Our first example, factor completely r squared minus 25. Anytime we're asked to factor, again, the first thing you want to do is check to see if there's a greatest common factor, something that we can take out of all the terms in the polynomial. So we've got r squared and 25, nothing in common there. So I'm going to go ahead and put a line through the greatest common factor part. Second, it's a binomial where we've got two terms, and for those, it's only three ways to factor, and here I've listed them: difference of squares, and that word difference means subtraction. Squares we'll talk about in just a second. Difference, again, that means subtraction, and this last one, sum of cubes. Sum means addition. So for the example we've got here with a minus in the middle, definitely not going to be sum of anything. This minus indicates it's going to be difference of something. And below here, I'm going to make a list of things that are squares. And squares can be made by squaring something. So I'll sort of outline the thinking: 1 squared, 2 squared, 3 squared. And the actual numbers: 1 squared is 1, 2 squared is 4, 3 squared is 9, and then so on. 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared. You'll probably want to make a list like that so you can reference it. 4.7 is mainly going to consist of difference of squares and difference of cubes. As far as square variables go, x to the second would be the first, x to the fourth is the second. That's pretty much the only square variables that you're going to see. As far as cubes go, these are numbers that can be made by cubing things. So the thinking is 1 cubed, 2 cubed, 3 cubed. I'll put this in thought balloons. So that's the thinking. In the actual numbers, 1 cubed is 1 times 1 times 1. So that's 1. 2 cubed is 8. 3 cubed, 27. And then we'll continue on. 4 cubed, 64. 5 cubed, 125. You can make a longer list than this. Obviously, that keeps going. As far as cube variables go, the first one is x to the first cubed, which is x to the third. And then x to the sixth is the next one, which is x to the second cubed. And that should be about all that you see with those. So if you've got your list of squares, your list of cubes, and you're looking at this binomial here, hopefully you notice that it's the difference of squares, since r squared, basically the same as x squared. It's a variable term that's squared. So r squared is a square, and then also 25 is the square of 5. So the difference of squares, and I'll zoom in on this just for a second. Difference of squares, the formula is a minus b, and then a plus b, where a is the square root of the first term, and b is the square root of the second term. So in this case, a, zoom back out, a is the square root of r squared. So a is going to be r. Square root of r squared is just r. And then b is the square root of the second term. So the square root of r squared was r. The square root of 25 is 5. So if we've labeled it difference of squares, and you'll probably want to go ahead and do that, you might write difference of squares when you're working these problems, just to remind yourself what you're dealing with. So it's going to be a minus b and then a plus b. A is r minus b, which is 5. And then a again plus b. One more thing I want to throw onto our list of squares. If you look at the variable squares, x to the second, x to the fourth, the pattern kind of continues. The next one would be x to the sixth, x to the eighth. Just want to add those real quick. Example number 2, factor completely 64b squared minus 81f squared. Again, anytime you see that word factor, you'll want to check to see if there's a greatest common factor, GCF, something that we can take out of both terms. 64 and 81 don't have anything in common. Not going to be able to take b out of everything. There's no b in the second term. Can't take f out of everything, so there's no f in the first term. So no greatest common factor. Next, it's a binomial. It's got 2 terms. So only 3 ways to factor that. And by the way, if it's not one of these 3, then we would say that it's not factorable. So this one has a minus in the middle. So it's definitely going to be either a difference of squares or difference of cubes. And if you've got your list, hopefully you made a list that you can reference while you're doing the homework. 64 is a cube and it's also a square. But the b squared part of it, that's only a square. 81 and f squared, also only squares. So this is going to be difference of squares. So difference of squares, just a reminder, a minus b, a plus b is the formula for that. A is the square root of the first. So since the first term is 64b squared, the square root of 64 is 8, and the square root of b squared is b. So the square root of that one. Then the square root of the second term, the 81f squared. The square root of 81 is 9. The square root of f squared is f. So that's our a and b. Just plug that into the formula. A, which is 8b, minus b, which is 9f, and then a plus b. Example 3, factor w cubed minus 8. Just go through our basic steps. First step, greatest common factor. W and 8 are not going to have anything in common, so we can move on from there. Second, again, it's a binomial. So you want to look at your list of the 3 different ways we can factor a binomial. Difference of squares, difference of cubes, sum of cubes. This definitely is not sum of anything because we got a minus there in the middle. So difference of squares or difference of cubes, if you're looking at your cubes list and your squares list, you'll see that w cubed is on the cubes list and so is 8. So this would be difference of cubes, and you'll probably want to list that as you do these, just to get in the habit of it. It'll cement it in your brain. So we got difference, let me write that a little bit neater, difference of cubes, which the formula for that is going to be a minus b, and then a squared plus ab plus b squared, where a, instead of, like with difference of squares, a was the square root of the first term. With difference of cubes, a is the cube root of the first. Not going to be too complicated. The cube root of w cubed is just w. B is the cube root of the second term. So the cube root of the 8 So I'll write beneath this a, which is the cube root of w cubed, is just going to be w. B, the cube root of the 8, is 2. 2 times 2 times 2 makes 8. W makes w to the third. So then from there, just filling into that formula there, we've already labeled a and b. So a minus b. And then we want to square a. If we're squaring w, it's just w squared. Plus, we're going to multiply, if you look at the formula over on the right, multiply a and b, which means you could write w2. Putting them up against each other indicates that we're multiplying, but typically we don't write w2, we write 2w. And then lastly, we just want to square b, since b is 2. If we square it, we've got 4. Number 4 says factor w to the 6th minus 64. Put a little star next to this one. This one is one of the ones that might seem a little bit more involved than the other ones. But if you go through your steps, factor, anytime you see that in the instructions, you'll want to start with greatest common factor. See if there's something that you can take out of everything. Most of the time there won't be. Nothing we can take out of both of those terms here. Second, it's a binomial. Again, like a lot of these will be in 4.7. And is it difference of squares? Is it difference of cubes? That's where the star on this problem comes in, because it is difference of squares. W to the 6th is a square. 64 is also a square, the square of 8. But w to the 6th is a cube, and 64 is a cube also. So this could be difference of squares, could be difference of cubes. I would recommend that you start with difference of squares, and then we'll work it out from there. So difference of squares is going to be a minus b, a plus b, where a is the square root of the first. So the square root of w to the 6th is actually w to the 2nd, or let me take that back, w to the 3rd. Since w to the 3rd squared is w to the 6th, and b is going to be the square root of the 64. Square root of 64 is 8. So over here, a minus b, and then a plus b. Okay, and then here's where some things get unusual, because on some of these we can factor further. So factor further. So we've got w cubed minus 8, which w cubed is a cube. 8 is also on our cubes list. W cubed is a cube, and 8, I should make that look more like an 8. W cubed plus 8. So we've got difference of cubes in the left parentheses. We've got sum of cubes in the right parentheses. So like I said, difference of cubes. And for this one, we've got the sum, since there's a plus in the middle, of cubes. And you might take a second and label what your a and your b are. A is the cube root of the first one. The cube root of w cubed is w. B, the cube root of the second term, the 8, is 2. And that's going to be the same for both of these. A is w again, and b is 2. So since we're doing cubes, all right, the formula for the difference of cubes, that was a minus b, a squared plus ab plus b squared. Hopefully you have that written down already. Also, sum of cubes, which is a plus b, starts with a sum, and then a squared minus ab, and then plus b squared. So these two formulas look a lot alike. The only difference is the first two signs. Different starts with plus, or different starts with minus rather, and then goes plus, and then sum starts with plus, and then goes minus in the next sign. So if we do difference of cubes just to start with, we know A is W minus B, which is 2. And then we want to square A. And then add those 2 multiplied. And then add B squared. B is 2. So if we square it, we get 4. So that's just factoring that first parentheses. And if we're factoring the second parentheses, I'll do this in blue. Still going to be A, except we're doing plus B. And then squaring A. Subtracting A times B, which is 2 times W. And then adding B squared. B is 2 again, so B squared is 4. So a pretty involved problem there. You won't see a lot of these, but you had to factor both of those parentheses after the first step. Example 5, factor the following expression completely. We've got MC plus CK minus MQ minus QK. And generally these ones, first off, factor GCF. Not going to be able to take M out of everything. Can't take C out of everything. Second, this one's not a binomial. This one has 4 terms. These ones we're going to group and factor after we group. So when I say group, if we look at the first 2, if we consider graphing the, or let me erase some of this. So if we consider grouping these first 2, MC and CK, hopefully you can recognize that we could factor a C out of both of those. If we group the second, or the third and the fourth terms, we could take a Q out of both of those. And that's actually what we want to do. We're just going to group them into pairs that have something in common. So if I do sort of a, I like to do a dotted grouping, just so I can still see what it was at the beginning. So MC plus CK, and I'm going to factor out a C and then rewrite what's left. If I take C out of MC, I've got M. If I take C out of CK, I've got K left. And then for the second parentheses, if the thing starts with a minus at the beginning, you'll probably want to factor out a negative. Q was the thing that was in common, but we'll take out a negative Q. And then we'll rewrite what's left. You take negative Q out of negative MQ, you got an M left there. And I do want to highlight the fact that if you take negative Q out of negative QK, it's going to be positive now. And just a K is left there. And once you've done that, ideally this binomial part, the parentheses part, is exactly the same. So we got M plus K and M plus K that we can factor out again. So we got M plus K, and then we're going to multiply that by what was left when we took M plus K out. C and negative Q. And number 6, this is our last example. Factor completely. Negative 3x squared plus 8x to the third plus 16x minus 6. Factor Greatest common factor. Not going to be able to take x out of everything. No x on the end. And if you look at the numbers 3, 8, 16, and 6, no common factor there. It's not a trinomial. It's not a binomial. This one has 4 terms. So we're going to group and factor. One thing I want to do at the start, though, is this is not in descending order. This is not in descending order, and generally when you're factoring, you do want your terms in descending order. So, which means that this x cubed and the x squared should probably be swapped. So you've got x cubed term, and then x squared term after that, and then x to the first term, which is this 16x, and then basically x to the 0, which is this 16. So I'm just going to swap those. Make sure when you move them that the signs stay the same. The 8 is still positive. The 3 is still negative. Then it's going to be 8x cubed minus 3x squared. And then the 16x and the 6 still in the same spot. So once you put it in descending order, then we can go ahead and group. I'll do that in blue. Group the first two. Hopefully you notice we can take an x squared out of both of those. And then grouping the second pair. With those ones, we can take a 2 out. So x squared out of the first pair, and that leaves 8. And we took out 2 x's, so that leaves 1. Minus, we took out 2 x's, and that just leaves a 3 in that second term. Moving on to the second parentheses, factoring it. Like I said before, we can take out a 2. That's a positive 2. And then we'll just rewrite what's left. If you take 2 out of 16, you've got 8. We didn't take any x's out, so we still have that 1x. Minus 2 out of 6 leaves a 3. And hopefully you notice we got the same parentheses there, 8x minus 3, 8x minus 3. So let's go ahead and take that out. And then we're going to multiply it by the things that were, the factors that were left when we took out the 8x minus 3. So the x squared was left and the positive 2. And that's our answer.